Here are our two versions for the equation of a parabola. The top one is the one that we're most familiar with. We have x is squared, y is not. So you can imagine if we multiply everything out and rearrange a little bit, I'm going to have some version of y equals x squared, and that's our typical parabola that you've probably seen before and are used to. This parabola opens up if the value of a is positive, you might remember, and down if a is negative. The second version, instead of y equals x squared, we have x equals y squared. Again, if you rearrange a little bit and zoom way out, the essence of it is x equals y squared. This version of a parabola is going to open left or right, and in particular, it'll open to the right if a is positive, and that's the positive x direction, right? So the y equals x squared version opened up the positive y direction when a was positive. So this one's going to open the positive x direction to the right when a is positive, and left if a is negative. There's a bunch of stuff in here. Let's take a look at all this stuff and see what it all means. Any parabola is going to have a vertex, an extreme point, and that vertex is its point h comma k. Notice that regardless of version, h is with x, k is with y. So h is the x coordinate of the vertex, k is the y coordinate of the vertex. So let's see, I'm going to have a parabola open here, over here. There's my vertex. We'll build it up as we go. Coordinates of my vertex are h comma k. And then we have this a in here. A actually gives us a bunch of different information about the parabola. The first thing it tells us is the distance from the vertex to the focus. So if I start at the vertex and go a distance of a, the focus is on the inside point, on the inside of the parabola. So there's my focus. And this distance is a. Actually, I'm going to do this. Since we said a could be either positive or negative, and I'm talking distance here, distance is always positive. So the absolute value of a is the distance from the vertex to the focus. It's also, this same character, a, is the distance from the vertex to the directrix. I'm taking the cheap way out there. The directrix is a line on the outside of the parabola, so the opposite direction from the focus. If that's a point on my directrix, directrix is a line, no, not a point, so it's going to go that way. And this distance from the vertex to the directrix is the same, also a. And we're not done with a yet. You notice in the equation what we see is 4a. 4a, and again that's 4 times the absolute value of a because we're talking distance here, is the length of the lattice rectum, is the technical term. Seems like a muscle or something, doesn't it? But it's not. It's just a segment. We can also regard this as the width of the parabola through the focus. So if I go from the focus, let's see, we said this is a distance of 2a each way. So there's one A, there's another A, there's 2A. And I'm going to go the other opposite direction. There's one A, there's another A. So that's 2A. That gives me 2 points that are on the parabola, on the edges. So now that I have a vertex and 2 points on the edge of the parabola, I can connect the dots and get a complete graph. Here it goes. And there's my parabola.